Good day. My report is all about armature construction and ventilation. Armature construction. So as we can see in the picture, we have here the two components. The upper one is the armature yoke or the frame support, and the lower one is the armature stampings. We define yoke as the outer hollow cylindrical frame to which main poles and interpoles are attached and from which the machine is secured to the base. It supports the pole force and protects the inner workings of the machines mechanically. And then it gives the magnetic flux a low reluctance direction. The purpose of armature is to rotate the conductors in a uniform magnetic field. So as the armature rotates in a magnetic field, electric currents are induced in the wound wires and electric currents are induced in the wires. It is not only to support the armature coils, but it also acts as a low reluctance direction for the magnetic flux, just like I've said earlier. The armature core is made up of thin silicon steel lamination, with each lamination insulated by other thin paper or a thin varnish coating. Since the armature induces alternating current in DC machines, it is made of laminated grain-oriented silicon steel. Two types of rotor, the cylindrical rotor and the salient pole rotor. The first one is the slow-speed salient pole type alternator. What is salient? So salient means projecting or protruding. So the salient pole type of rotor is generally used for slow-speed machines having large diameter and has a relatively small axial lengths. So the pole in this case are made of thick laminated steel sections that are riveted together and attached to a rotor with the help of a joint. So sabi dito, these are cooled sufficiently by natural movement of the air around their field coils and windings. The second type is the high-speed non-salient pole alternator. The construction of a non-salient type rotor, or also called as a smooth cylindrical type, this is used in very high-speed applications like turbo alternators. It is usually driven by steam turbines. The rotor consists of a smooth solid forged steel cylindrical having a number of slots on its outer periphery for accommodating rotor winding. We have differences between the first one and in here. In the first one, more number of poles are present, while in the high-speed non-salient pole alternators, two or more poles are present on the rotor. In the slow-speed salient pole type alternator, water turbines are preferred, while in here in high-speed, steam turbines are prepared. So the slow speed, the construction is complicated, then while in high speed, it is easy to construct. And in here, it is perfectly balanced, while the other one is perfectly not balanced. Dito na tayo sa cooling of synchronous generator. Cooling of a synchronous generator is important. Sabi daw, natural cooling is insufficient to dissipate the considerable heat produced by the alternators. That's why in the forced air cooling system, as the name itself, air is forced into the alternator so that a greater quantity of air is passed over the surface, and of course, a large amount of heat will be removed. The closed-circuit ventilation system is used for better cooling of the synchronous generator. In the closed system, clean, hot air from the alternator is cooled by the water-cooled heat exchanger and forced through the alternator by fans. So yung sa fans, ducts are provided in the stator and the rotor cores, and also in the field coils of the generators or machine for increasing the surface area which is in contact with the cooling air. Of course, it depends upon the direction of airflow. These ducts can be radial or axial. Yun yung matatakal natin later. kung what is radial and what is axial. Ventilation system, two categories, the induced and the forced. Sa induced, fan, arrow, decrease in air pressure inside the machine. Air sucked in, push out by fan. And then sa forced naman, nasusuction ng air from atmosphere, forces it into the machine, and then air push out. So that's the differences between the induced and the forced. Types of ventilation system. So nabanggit ko to kanina, yung radial and the axial. The first one here is the radial flow ventilation system. In the radial flow ventilation system, the cooling air enters the ducts through stator by way of the air gap and passes radially to the back of the stator from where it is removed. So sabi daw, most common up to 20 kilowatts rating and is used in the large machines. Siguro, most common use sa large machines, with a large core length. Pero nagagamit din to sa small machines. Isa yun sa advantages niya. And then, the energy loss for ventilation is minimum. Sa disadvantage naman niya, the heat dissipation is less as compared to the other system. On certain cases, the system becomes unstable because of the quantity of cooling air flowing through the machine. The second type is the axial flow ventilation system. Dito naman, it is used in induction machines, which has a medium outputs and with high-speed machines. One of its advantages naman is it is highly effective except for machines with considerable axial length. One of its disadvantages naman is ventilation is not uniform heat transfer. The air outlet part of the machine is cooled less kasi daw the air in passing through the axial ducts has time to become heated. That concludes my report. Thanks guys for listening.